For number 12, we know how we always start these. If we're finding zeros, we set the whole thing equal to 0. And first thing, we look for a greatest common factor. If we look at all the numbers, they all have a 3 in common. And if we look at the x's, they all at least have x squared. So we can factor out x squared. And we'll write here what remains. It's minus 9x, and 54 divided by 3 is 18. And so that 3x squared, as always happens with greatest common factors, this is just going to come along for the ride. But within the parentheses, we need to look at what we have. We have 4 terms. And if you have 4 terms, you're going to use factoring by grouping. It's pretty much the only thing that might potentially work. So I will note here, we've got that as our first 2 terms for factoring by grouping, and those as our second 2 terms. So 3x squared comes along for the ride. Looking at this first pair, what they have in common is x squared, leaving x plus 2. Now looking at the second pair, it starts with a negative, so I'm definitely going to factor out a negative, but they also have 9 in common. So we'll factor out minus 9. And what remains there is x, and then negative 18 divided by negative 9 is positive 2. We'll check, as we always do at this point, that those 2 terms are identical. They are, so that's a good sign. And we can do the next step of combining what's in here into 2 factors. So x squared minus 9 combines, and then x plus 2. We've finished that step. So now we'll look and see if there's anything that can still be factored further. 3x squared, that's fine. X plus 2 is fine, that's linear, but x squared minus 9, can that still be factored? Well, let's see. It's a binomial. There's 2 terms. It's a difference, and it is in fact a difference of squares. It's x squared minus 3 squared. So we can factor this part as a difference of squares. X plus 3, x minus 3, and then the x plus 2 from the line above. All of these terms are fully factored now, so we can set each one equal to 0. This is x squared. It gives us 2 solutions. So 0 with a multiplicity of 2. This gives us x equals negative 3. This gives us x equals positive 3. And this gives us x equals negative 2. We've got 2 solutions or roots, 3, 4, 5. And this started out as x to the 5th. So we got exactly what we should.